Hey everybody, welcome back. My name is Deez. This is my workshop. Today's project is going to be a cool one. This came as a suggestion in one of the comments from one of my viewers. I thought it was a fantastic idea. Today we're going to make a poor man's indexer. And the idea was suggested to use a degree wheel. When that was first suggested, I'm not a mechanic, and I was like, what's a degree wheel? Well, it's something they use on motorcycles and other things for mechanicking. I didn't do a lot of research, but I did find a degree wheel. And I thought, you know what? I really like the concept of that. I don't have a really cool indexer like a lathe chuck, where I know if you watch Keith Rucker or Adam Booth or many of the big guys, they've got the lathe chucks where you can mount in your workpiece, especially on a mill. A milling machine, this is very handy. If you think about wanting to turn like a hex nut with 6 equal sides, you mount up your round stock and you set your degree points so that you have 6 equidistant points, and you mill off one of the faces, you rotate it a sixth. Forgive me on the degrees. You rotate, you mill off that flat, rotate it again, mill off that flat, rotate it again, until you have all 6 sides, and now you have a equal proper nut with all the right sides, so that you can use wrenches or sockets or whatever you need to do. Well, I'm not at a point where I want to buy a indexer, especially a chuck mounted one. I don't have a mill yet, so I'm not ready to buy anything like that. However, if you recall, if you've been watching my channel, you'll recall that I made the tailstock die holder. The tailstock die holder, I was originally going to put 3 equidistant set screws so that I could mount in my hex dies as well as the round dies that I had. And I ended up abandoning that, and I just went with 1 set screw. So I didn't really need it in the end for that project, but in the future I might be working on projects where that could be very handy, where you want to make a mark equally around. So the idea is to mount this to the headstock in some fashion. I'm going to use the spindle bore and make an indicator somewhere on the headstock to point at any varying position. Make your first mark on your workpiece, rotate it whatever, 180 or 120 degrees or whatever your increments require. Make your mark, rotate it yet again, make your mark, and now you have your workpiece properly indexed. Great idea. Simple solution. So that's what we're going to try to tackle today. We're going to take some measurements. I'm going to draw up a plan, just an idea of what I want to do, and then we're just going to get after it and make this thing and give it a test and see how it works. This will either work or it won't, but I think it's going to work out really well. Hopefully you find this interesting and you enjoy. Thanks for watching. Let's get started. So the idea is to mount that degree wheel somehow in the spindle bore, so that when I decide to index a part, I can just rotate it whatever increment that I need, rotate it again, make my mark, rotate it again. I don't think the precision is absolutely accurate. I just need to get it mounted in here so that when this rotates, the wheel rotates, and then I can make my mark. It doesn't need to be just absolute precision, and I just need to get it in there so that it stays, doesn't move around as I rotate this thing. So I think what we need to do first is take some measurements, and I don't know, it really would be nice to have some an inside micrometer or gauge pin or something where I could then measure it, but I don't have that. So what options do I have? There's also a step in here where this is kind of bored out. So what can we do? Let's give this a shot. So I have these spring-loaded indicators or calipers. They're not you know, they're measuring instruments so that you can then measure the tips, the various applications. But what we're going to do, obviously that's too big. Let's get this in here. Making this a little bit bigger here. There we go. So it's in there tight now. So what we want to do is snug this up. And that's our measurement. So if I run this in, it's a little tight all the way down. That's basically what that bore is. It's supposed to be a Morse Taper 5. I believe it should be bigger on this end than on the other end, but I think the Morse Taper is up here. I don't think the whole thing is an actual Morse Taper 5. Regardless, this is the end where my degree wheel is going to go in. So now that we have a rough idea, we can measure that and see what kind of materials we need. If I can get it on there. Oh, come on. So 1 inch, it's 1.5 inch, 1/510. So that's kind of the material we're looking for. 1 inch, 512 thou. So let's see what kind of materials we have. My initial thought is to use Delrin or nylon, and I have this material here. How big is this? This is just under, it appears. But this might work. Let's just test fit it anyway. It's under according to this, but then again, if you noticed, I put this in here and it's still raking. So that means it's compressing a little bit, and we're talking, 10 thou. So maybe this will work. Let's see what it feels like in there. It kind of stops. Wait a minute. Oh, if I just give that a shove, it might be a little loose. That's obviously way too, I don't need anything that far in there, but I don't see why that couldn't work. Heck, that goes, wow. I could almost use that entire bar and then save it for projects later. Huh. Well, the original design was going to be, I think I'm going to regroup and change things up a little bit, and I'll explain why. Let me bring you over to the workbench, and I'll draw out what I was originally going to do, and then I'll explain what I am going to do. Okay, everybody, this was my original plan. in my mind what I was going to do. And I'll stick this up here in case anybody wants to screenshot that. Maybe they want to steal the idea or modify it for their lathe or their setup situation. But I still think this is a solid plan. But I'm going to make a slight change. I think what I'm going to do is do this same original design. Let's talk this out. What we have our headstock over here. This is our spindle bore, which is 1.5 inches roughly. We measured it with the spring calipers here, but in the end I think it's actually right on at 1.5 inches, or at least for this material. But the idea was to originally mill down 1.5 inches, you know, turn it down, not mill it down. And I was almost going to use some very large stock and just really whittle it down and put an actual taper, slight taper on this, on the Delrin. And that way when I wedge it in there, it will actually wedge and just stay put. It doesn't need to be fixed with any fasteners. It just needs to be kind of wedged in there to stay put so you can do your indexing. So I think for version 1.0 of this project, we're still going to go with that concept, but what I'm going to do is I'm not going to bother with the taper. When I was measuring, if you just saw a few minutes ago, this slides right into my spindle bore. Now, it is it's a little rough because of the casting and everything, but it slides in there good enough. The entire piece almost slides all the way in. So I think what I'm going to do, rather than hack this piece of Delrin up, what I'm going to do is leave this intact. That way I have it for future projects if I need to use this for something. So I'm going to leave this entire piece intact, but I'm still going to go with this concept of turning down, facing off the ends. And since this sticks out far enough, I don't need to do this little turn down nub. I really didn't need to do that anyway, but that was the idea. The original idea was to stick it out a little bit from the spindle bore, but I needed to have a little extra to clear the mounting. If you looked at the covers on the back of my headstock gear cover, I've got 2 thumb screws to fasten that on. Those are about a 1/2 inch thick. I have to clear that or this degree wheel won't spin. It'll interfere with those. So since it sticks out just right, I think the only turning I'm going to do is face off both ends so that it's flat, and then I'm going to go ahead and just drill a center hole. And I think what I'm going to do, I'm not even going to thread the hole. I think I'm just going to use like a wood screw, and since it's Delrin, and we're going to mount the degree wheel right to the back. We're going to keep this project very easy, but I think in the end this is going to work out very well. Down the line, if I decide, okay, I need to use this for another project, I'll go ahead and recreate this, but I'll use some different material and I'll make a dedicated piece with a taper like my original design. But for today, I think I'm just going to go with this. You don't always have to make a project super complicated. Let's go with the easy solution, since that's the materials I have. But I did describe what I was going to do originally. If you don't have the same, if things don't work out for you like they did for me, you might have to go with those plans or that concept. Either way, it's not going to be a complicated project. So let's get started on this, and we'll face off the ends. We'll do a center drill, and we'll get this thing mounted up to it. And then we'll do some test indexing, because we still need to make a mark on the headstock in order to mark where we want that to be. But what we're going to do is get this going, get our ends faced off, do our center drill, mount that up, and see what we end up with. This is not right and proper. Way too much stick out. I don't have a steady rest, but it's Delrin. This isn't critical components. So what we're going to do is just stick it way out, because I don't want to hack this piece up. Let's see if we can get you adjusted to where you can actually see what's going on here. Mounted a little farther back this time. Let's this is what we're gonna do. This isn't right. You normally would never do this, but again, what I'm trying to do is just shave this off a little bit and face the ends off, and I just need to get a center drill in there. So none of it's critical, but just trying to make it to where I can mount the degree wheel. Let's get that turned. We'll go with that. Let's see how this goes. This is not normally what I would do, but that's what we're going to do today. Clean this up. All right. Flip this around, clean off the other side. Now it fits in there. Well, we're going to take advantage of that. That'll do. Just close enough. To get this cleaned up, we'll get a drill chuck mounted in the tailstock, and we'll get a center hole in there. We'll drill a small hole so that we can put in a screw and mount the degree wheel. Let's get this going. Pretty easy operation. Out of there. And then this will ultimately thread in here. Plenty of extra material to kind of bite in. And again, this, I might need to drill that out a little bit bigger, but that's what we're going to start with. Let's see how this mounts. think I might go with a little bit bigger of a drill. That's a little bit of a small hole, and I don't want to crack the Delrin. So let's step that up a little bit. There's our degree wheel. There's our screw. We're going to see how this mounts. Oh, that's better. There we go. I don't see why that won't work. Okay. I like it. Mock project. Everybody, it's imperative that I get 6 equal spaced holes in this piece. So I need to mark those out. How am I going to do that? Well, I got an idea and I made a tool. What we're going to do is take our degree wheel and our mounting system that we made, and we're going to get this put in there. If you can see that a little better. Okay. And then we got to put our degree wheel on there. Of course, it's going to have to go backwards so we can see it. So that's going to go right there. Just get that started. And we're going to screw that in. And then we're going to see how we can get this piece marked out. Now, we need to rig up some sort of indicating mechanism here, and I don't see any reason to get too fancy. So if we were to take a scale, something like this, bring you down here and show you what I'm doing. But I don't know why this wouldn't work. Could also do it back here. Maybe we'll do it that way. So the idea is I'm taking this scale and I'm just going to fasten it. I'll use some tape so that I have a marking point where I can line up my degree wheel. It doesn't matter where this is, as long as you know the markings that you want to use. So I'm going to use this as an indicator for which degree that I'm at. Let's grab some tape. You could get fancy and make more of a permanent solution, but I don't see the need for no more often than I'll probably need this. So we just take a little bit of a setup here. It's not perfectly centered, but I don't think that will matter too much. And there we go. So, well, now what we want to do is we also need a mark or an indicator up here in order to start our pieces. So what's the best way to do that? I mean, we could use something off the back side here. Maybe that's what I'll do. Let's find another device. See how that works. Here's a scribe. Which can be our pointer. I just don't want it moving at all, or it could mess up. Again, this is just there's ways to improve this. This is just kind of a proof of concept. Whenever I get my degree where I want it to be, I make my mark, move on, make my mark, move on. We're going to see how well this does. Yeah. So with that there, I can just make my mark, move it around, make my mark, move it around. Let's give this a shot. All right, we want 6 equidistant holes in theory on my workpiece here. So we're going to go every 60 degrees. So let's get this started at 60 degrees. Now, this is very rough. It's a very rough test. This is not what I would call precision, but this just gave me a very good, pretty close, equidistant 6 holes that I could drill into this material if I needed to. So now that we have that done, let's take our marking tool off of here. And I want to bring you down and show you what we have. Here's another video clip I wanted to show you just to see. I can get closer with this camera. But you can see there's a mark. There's a mark. There's one. There's one. There's one. So those are all 60 degrees from each other. Pretty close. I mean, this isn't total precision. You wouldn't necessarily want to use this on a milling machine, but if you're just working on some projects in the garage and you just need to get your markings on your workpiece pretty close to being equidistant, this is a good way to do it. You can see there's my redneck marking system, but you know, there's a number of ways to make this look better and be more functional. But there we go. I could even bring this in closer so it's not so far away, but that's pretty solid. You know, you rotate this thing around and you have your degrees that you can mark. Works very well. And then when you're done, you pull that thing out of there and now you have your workpiece marked. So overall, pretty happy with this capability. I didn't have this capability before, but I do now. So there's ways to improve it. Feel free to take this design, improve it, make it better, share it with other people. But hopefully that inspires you to make an indexing system on your own. Total parts, cost of materials, I think this thing was 15 bucks. That's it. Nothing to it. Anyway, hope you enjoyed. Let's do a recap. So this is our poor man's indexing system for a mini lathe. Pretty simple. It ended up being much easier for me to make for my mini lathe because of the 1.5-inch spindle bore. However, the same concept will apply to anyone, no matter what size spindle bore you have. You find yourself a piece of nylon or Delrin. You could use aluminum if you wanted to, but you create a mounting system for a degree wheel, hang out the back of your headstock. I was going to put a taper on this so that I could just kind of wedge it in there so it doesn't move and it stays put just during the operation, but I didn't need to, and that leaves me my entire piece of Delrin intact for a future project if I need it. But for today's purpose, I was able to face off both ends of this. I drilled a hole so that I could put in a just a wood screw, basically, and that mounts my degree wheel. It's not 100% concentric, or maybe it is and the tailstock wobbles a little bit. It really doesn't matter. I'm just trying to get my increments in whatever degree, 180 out, 120 degrees out, 60 degrees out if you need 6 sides. But you know, this gives you that ability when you're working on a workpiece to incrementally make some markings on here so you can continue operations and have a little bit more precision than if you're just trying to measure in other ways. It's also easier or cheaper than buying a chuck that's an indexing system, an indexer that you mount a lathe chuck to and try to, you know, those are very, very nice. They're if you need precision, that's the way to go. That's the kind of thing you would need on a milling machine if you're making hex nuts, things like that. But for me, for now, this is a great option for if you just have a mini lathe. This is a great option to be able to index parts. So I've got some close-up videos. I've inserted them into the video. I'll put some at the end here just so you can see. But anyway, easy project. I encourage you to make one if you need to index parts. Another tool making video. Anyway, thanks for watching. I hope you enjoyed. Please subscribe if you haven't, and I hope to see you on the next one.